Hello, boys and girls. Hopefully you did well on your Unit 4 assessment on scientific notation, but whether you did well or not so well, it's time that we learn from our mistakes. So please get out your test correction forms. I'm going to go through each question one at a time, and make sure that you fill out each column. You need to write down the number of the problem, show all your work, and correct answer in the second column. And the third column is the most important column. That's where you need to explain where you went wrong, what you did wrong, what you didn't do that you should have done. Be as specific as possible. Thank you very much. Let's get started. Boys and girls, let's take a look at our assessment. Let's go to part 1, identifying scientific notation. Remember, in order to have a number in scientific notation, you have to have a coefficient that is between 1 and 10, and that coefficient needs to be multiplied by a base 10 number, okay, which basically is 10 to a power, and that power has to be an integer. So let's look at number 1. Circle the only expression below that is in scientific notation. We'll look at A here. We have 6.33 or 6 and 33 hundredths, which is definitely that coefficient's between 1 and 10. That passes that check. And it's also being multiplied by a base 10 number. So A is correct. And when we take a look at B, we see here that the coefficient is too large. Okay, that coefficient is greater than 10. And for C, we see that the coefficient is too small. It's less than 1. So B and C disqualified. They are disqualified from being scientific notation. Number 2, circle the only expression below that is not in scientific notation. Well, when I take a look at A, I see right away that this A is disqualified because I have 10.1, which is greater. Okay, that is greater than 10. Therefore, this is not in scientific notation. But on the other hand, B, we see its coefficient is between 1 and 10, and it has a base 10 number. So that wouldn't be not, it is in scientific notation. The same thing is true of C. We have a coefficient of 1 and 1/100th. Times 10 to the 0 power. And even this might look a little weird, but it basically would be equal to that. And it is in scientific notation. B and C are in scientific notation. A is the only one that is not. Our next section deals with putting things from scientific notation to standard form. And when we want to convert something from scientific notation to standard form, it's as simple as just following the directions. Remember, the exponent here, this exponent here, is in charge of 3 things. Okay, it's in charge of the decimal point right there, and it's also in charge of the direction of the decimal point and the distance that it'll travel. I like to refer to it as the 3 Ds. The exponent is in charge of the decimal, the direction of it, and the distance. Since it's a positive exponent, we know that we're going to be traveling to the right, and we're going to be traveling to the right 5 places. So basically, I have to go past the 5, that's 1, and then 4 more empty places, which will take it to there. And we will have, so what I did was I took it past the 5, that's 1, 2, 3, 4, 5. I had to go 5 to the right, and that will give me 450,000. Let's take a look at number 4 here. The exponent is a -1, so that's telling me to move the decimal point 1 place to the left. If it's a negative, I'm moving it to the left. I'm actually dividing it by 10 rather than multiplying it by 10. So that would be 0.90000. Yep, there's 4 zeros and then a 3. Number 5, I have a +6 as my exponent, so it's telling me to move the decimal point 6 places to the right, which would be 1, 2, 3, 4, 5, and then 1 more place past the 6. So that's going to be 1, 2, 3, 4, 5, 6, and then fill in that empty spot, the empty placeholder, with a 0. So my answer would be, so I have a comma there and a comma there, 1,234,560. This next one, number 6, is interesting. My exponent is a 0. So it's telling my decimal point to move neither to the left nor the right. It's not going anywhere. So it's not that exciting. It just stays the same. The coefficient is actually the number in standard form. So I have 5.5554. Nothing changes. And then my last one in this section, number 7, the coefficient is a 5, so it's telling me to move the decimal point 5 places to the right. So I have to go 1, 2, 3, 4, 5. Right between the last 2 and 1. So I have 8, 3, 3, 3, 2, 2.1. Part 3 has us transferring, or I should say converting, standard form to scientific notation. Now we're working on this in backwards mode. What we have here is we have numbers written in standard form. And the first step, and I think this is the best process, the first step is find out where I have to move the decimal point so that I use all of the non-zero digits up and any zeros that would be trapped between non-zeros. I have to make a number out of this that'll be between 1 and 10, greater than 1 but less than 10. So I would have to move my decimal point right there. Oops, let me get it. I'd have to move my decimal point between the 5 and the 4. So that would be 5.4321. And then I'd have to multiply it by a base 10 number. Okay, and this base 10 number, the exponent would have to move this decimal point back to its original place. And for me to get back to my original placement of that decimal point, I would have to move this decimal point 1, 2, 3, 4, 5, 6 places to the left. So that would be a -6. And there I have it in scientific notation. Number 9, I need to move my decimal point between the 1 and the 2. Okay, that'd give me 1.2. I need to multiply it by a base 10 number that would get this decimal point all the way back to its original placement, which is after the last 0. So I'd have to go past the 2 and 3 6 zeros. So to go past the 6 zeros and this 2, that's 7 places, and that's 7 places to the right. I'm moving this decimal point 7 places to the right so that this number here is equal to my original number. Or another way of looking at it is I have to get this decimal point back to its original place. Let's look at our number 10. Okay, now the only place where I can move this decimal point is between the 9 and the 8. Now this looks kind of weird, but let's go between the 9, 8, 7, 6, 5, 4, 3, 2, 1. Times 10, and again, I want to get this decimal point, my coefficient, I have to have a coefficient that's between 1 and 10, and this just fits in that range. It's a little high, but it still is under 10. And now I have to ask myself, in order to get this decimal point back to its original place, I'd have to move it past the 8, the 7, the 6, and the 5. That would be 4 places to the right, so that's a +4. Okay. And then let's look at number 11 here. I have to use these 3 digits here, the 3, the 4, and the 2, to make a coefficient that's between 1 and 10. So I have 3.42 times 10. Okay. And I need to get this decimal point back to its original place, which would be past the 4, 2, 0, 0. That would be moving it 4 places to the right. So that's a +4. And then last but not least, I look at 112.5. Now I need to make this a number that is between 1 and 10, so I'd have to make it 1.25. That's the only coefficient that would work for scientific notation. And in order for me to get this decimal point back to its original place, I'll just have to move it 1 to the right. So that's my exponent. And that's pretty much the process that you follow when you want to convert standard form to scientific notation. First, change the number into a coefficient that's between 1 and 10. You have to use all of the non-zero digits. Then you multiply it by a base 10 number, and that exponent would have to move this decimal point back to its original place. So just look at it over here. I have to go between the 5 and the 4 all the way back to up front here. Let's look at part 4, multiplying scientific notation. When we multiply in scientific notation, we simply multiply like terms. So if I have 7.6 times 10 to the ninth power times 1.5 times 10 to the third power, I'd first start out by just multiplying coefficients. 7.6 times 1.5. 5 times 6 is 30, carry the 3. 5 times 7 is 35, plus the 3 is 38. Put a 0 as my placeholder. 1 times 6 is 6. 1 times 7 is 7. I have to total this up. I'm going to get 0, 14, carry the 1, 11. I have 2 decimal places in my problem, so I should have 1, 2 in my answer. So the answer would be 11.4. I can drop the extra 0 times 10, and now I multiply my base 10, my exponents. 10 to the ninth power times 10 to the third power is really 10 to the 9 plus 3 power, which is 12. Now, the answer has to be written in scientific notation, and it is not. The coefficient is too large, so I need to make it 1.14. I'm just moving the decimal point one place to the left. And if I move it one to the left here, I'd have to move it back one to the right just to get it back to its original placement, and then an additional 12 times, which would be to the 13th power. These two expressions must be equivalent. The first expression is the correct answer mathematically. It's just not written in scientific notation. Let's look at number 14. Number 14, same thing. I start out by multiplying like terms, coefficient times coefficient, which is 1.01 times 9, which would simply give me 909. I have 2 decimal places in my problem, so I should have 2 in my answer. So it's 9 and 9/100ths times, here comes my power 10s, or my base 10 numbers, 10 to the negative third times 8, which would be 10 to the negative third plus 8, which is 5. When I add a negative 3 and an 8 together, that gives me a positive 5. And this is already in scientific notation, so I don't have any more extra work to do. Last but not least, my last multiplication problem on the test, I have 4 times 5.2, which I know right now is going to be 20.8. And then when I multiply my two power 10 numbers, or base 10 numbers, 10 to the 0 power times 10 to the second power is going to be 10 to the second power, because 0 plus 2 is 2. Is this in scientific notation? No. It's too large, the coefficient's too large, so I need to move the decimal point 1 to the left, which means in order to get it back to its original position, I have to move it once, and then 2 more times, which would be combined 3 times, so it's 2 8/100ths times 10 to the third power. Let's look at division. Now with division, and if you want to go back, remember you can always hit pause and replay any of these problems. For number 16 and through 18, I'm dividing scientific notation. Same thing, we have to divide like terms. So I'm going to divide coefficient by coefficient and exponent by exponent. And 8.8 divided by 2.2, I have to move the decimal point one place to the right, one place to the right. Okay, because can't have a decimal out here. And 22 would go into 88 4 times. 4 times 22 is 88 with no remainder. So that works out nice. So my answer is 4. And then 10 to the ninth power divided by 10 to the fifth power. When I divide exponents, I just subtract the powers. So that would be 10 to the fourth power. And it's already written in scientific notation. I don't need to change anything. Number 17. First, divide like terms, coefficient by coefficient, and then exponent by exponent. 3.4 divided by 5. 5 will not go into 3, but it does go into 34 6 times, which is 30. I subtract, I get 4. I bring a 0 down. 5 goes into 48 times exactly, with no remainder. And my answer would be 0.68 or 68 hundredths, and then 10 to the 4th power divided by 10 to the negative 7 power, it would be 10 to the 11th power. Now somebody's saying, how did I get that? Well, when I divide exponents, I subtract power. So it would be 4 minus a negative 7. And subtracting a negative, the only way I can subtract a negative is really by adding. So it would be 4 plus 7. And that's where I get the 11. Is this in scientific notation? No. I'd have to move the decimal point 1 to the right because 68 hundredths is too small. And if I move it 1 to the right, I would just have to move it 10 more times to get it 18. I have 1.4 divided by 7. Those are the like terms I have to divide. And then I also have I have 10 and 10 to the negative 4th power divided by 10 to the negative 7th power. Well, let's take 1.4 divided by 7. 7 won't go into 1, but it will go into 14 two times. 2 times 7 is 14. I subtract it, get 0. So this would be 2/10 times 10 to the negative 4th power divided by 10 to the negative 7th power would be 10 to, I have a negative 4 minus a negative 7, which is really a negative 4 plus 7, which would give me a net value of 3. This is not written in scientific notation. I have to move the decimal point over 1, which would give me 2.0 times 10, and since I already moved the decimal point 1 place to the right, I really only have 2 more place values to move it over. And that is my answer. Number 19 says, if a match has the mass of 3.5 times 10 to the negative 2nd power grams, and a case of matches contains 5 times 10 to the 6th power matches, that's how many matches, what would the mass of the case be? Well, if this is the weight of one match and we have this many matches in a case, we're multiplying. This would be 3.5 times 10 to the negative 2nd power times, there's 5 times 10 to the 6th power. That's how many matches we have in a case. We multiply 5 times 3.5. Okay, 5 times 5 is 25. Carry the 2. 5 times 3 is 15 plus 2 is 17. I have 1 decimal place in my problem, so I should have 1 in my product or answer. Then I multiply my base 10 numbers. 10 to the negative 2nd power times 10 to the 6th power is going to be 10 to the 4th power. This is not in scientific notation, so I need to move it decimal point 1 place to the left, times 10, and if I move it 1 to the left, I'm going to have to move it 1 to the right just to get it back to its original place, plus 4 more times. So that is 1.75 times 10 to the 5th power grams. Let's look at the next one. The next, number 20. You know what, I can keep that in there. Number 20 says, if the width of a felt marker tip is 2 times 10 to the negative 1 centimeters, I guess. Sorry, there's no unit of measures. And the width of a single bacteria is 5 times 10 to the negative 6. How many bacteria can fit? Okay. How many can fit across? So this is a division problem. Okay, the width is 2 times 10 to the negative 1st divided by 5 times 10 to the negative 6th. Okay, 2 divided by 5. Okay, I'm going to take 2 divided by 5. 5 will not go into 2, but it will go into 24 times, so that's going to be 0.4. And then 10 to the negative 1st power times 10 to the negative 6th power is going to be 10 to the negative 1 minus a negative 6, which is really a plus, so it's negative 1 plus 6, which is going to be 5. This is not in scientific notation. I need to move my decimal point over 1 to the right, so it's going to be 4.0 times 10. And if I moved it 1 to the right, I'd still have to move it 4 more times to get it to be equal. And that is all. Hello, boys and girls. As always, I hope that was helpful. And remember, when you're doing your test corrections, not only am I expecting for you to show all your work and your correct answer, but the most important part is giving an explanation for why you got the problem wrong the first time. And please don't say things like, well, I didn't know how to do the problem. Okay? Be specific. What didn't you know how to do? I didn't know that when I multiply an exponent times another exponent, I need to add the powers together. Or when I divided, I put the decimal point in the wrong place. Or when I was looking at the scientific notation's exponent and it was a negative, I moved the decimal point to the right instead of the left. Okay, be specific. If you didn't know what to do at the time of the test, say specifically what you should have done. Okay, that shows me that you've identified what you've done wrong, and once we have identified our mistakes, we can move forward. Otherwise, more than likely, we'll keep making the same mistakes. Okay, well, I'll see you in class tomorrow. Have a good day. Bye-bye.